Okay, so let's look at the other one, law of cosines. So we use law of cosines when we have an angle and adjacent sides. Usually just one angle, not sure why I put angles there. So we have an angle here, again, drew not a right triangle. We have an angle, and we have adjacent sides. And what we want to know is what that A is. So that's what we're kind of looking for. So, okay, we're going to go ahead and kind of start out the same way we did before. Let's just draw in, drop down a vertical so we can get a right angle. And that way we can at least get two triangles to kind of play with. And if I look at this time, I can again call this H. And since I'm using cosine, I probably don't want to set up sine of anything. That's just going to get me where I was last time. Plus, I only know one angle this time. So it is a right triangle though. So I'm going to start off going ahead and trying to do Pythagorean theorem. So let's see, we'll call this x. If that much is x, then this over here must be c minus x, because my whole thing's c. So this would be c taking away that x part. So I'm going to do Pythagorean theorem to my first triangle, and I'm going to get x squared plus h squared equals b squared. Pythagorean theorem to my second triangle, and I should get c minus x squared plus h squared equals a squared. Okay, well, again, I'm trying to figure out what that a is, so I'm just going to keep that over there. X and h I kind of put in there. So let's go ahead and solve for at least one of them, and I'll solve for h real quick. So h squared equals b squared minus x squared. Well, over here's an h squared, so I should be able to go ahead and just sub this into here. And while I'm doing that, I might as well FOIL out c minus x. So I should get c squared minus 2cx plus x squared. H squared was b squared minus x squared equals a squared. Well, this is getting a little bit better. X squareds cancel. So c squared plus b squared minus 2cx equals a squared. So it's better, but I still have an x in there. And again, x I kind of made up. I dropped down the vertical. Well, let's see if we can write x in terms of stuff that was given to us, and this angle was given to us. So this is an adjacent, that's hypotenuse, so I could write it as cos of A, because adjacent would be x over hypotenuse, b. So then x would actually equal b cos of A. Now I can just sub that in for my x. Might as well write in alphabetical order. So b squared plus c squared minus 2c, sub in that for x, so b cos A equals a squared. So this is a law of cosines. Usually what happens is you get a triangle, you get an angle, say 10 degrees, you have a side 2 and 7, and you're trying to find this other side. So you can call that other side something a squared and just sub in the rest. It's almost like the Pythagorean theorem. It's this side squared plus this side squared minus 2 times each of them times cosine of the angle. And that's going to equal the other side squared. So you still have to take square root at the end.